In this video, we are going to see how to implement a program in C for single circular linked list with a header node. In a single circular linked list with a header node, let us do the structure. For every node, there are two fields. One is information and another one is next. Next holds the address of next node and it contains two fields again, information and next. And last node contains the null, and there will be two pointers that will be pointing to the first node and the last node. So this is singly linked list. When it comes to circular singly linked list, the node contains information and next field that would be pointing out to the next node, and next node contains the information and next field, and next contains the address of the following node that contains information on the next. If third node is the last node, this next contains the address of first node. So this is single circular linked list, and there will be extra node that is last that would be pointing out to the last. When it is single circular linked list with header node, initially there will be a node names header. It does not contain any information, otherwise you can store the information like how many nodes are there in the single linked list. Then next contains the address of the first node. So this is the first node that contains information and next. Next contains the information of the following node, and if the second node is the last node, it contains the address of header node. So this is a circular single linked list with header node. Let us see how this circular single linked list with header node is used to represent this polynomial equation. For example, let us take the term 6x square y square z. Here 6 is a coefficient, 2, 2 and z power 1. So these are the exponential values of x, y, z. How we represent in the form of node. So in the node, this contains total 5 fields. First field contains the coefficient value, and following fields contains the exponential values of x, y and z, and the last node contains the address of the next node. So when you are using a circular singly linked list with a header node, it will contain another header node that contains the address of following node with 4 different fields, and the last node in the single circular linked list contains the address of header node. Let us implement. For implementing single linked list with header node for polynomial equation, let us divide the problem into subproblems so that it will be easier. First, define the structure. After defining the structure, let us go for global variables. What are the global variables that are required? After that, create header node. After creating the header node, next how to create a normal node, and joining them with the header node can be done by using insert function. After inserting the node into the linked list, let us check or display the elements. After displaying the elements, let's evaluate the single circular linked list with header node. Let us implement one after the other. Define structure. So definition of the structure. Here what is the structure definition? It contains total 5 fields. One is coefficient, exponential of x, y, z and next. If you observe here, we have defined the structure that represents coefficient of the term, exponential x, y, z and a next pointer that is pointing to the next node. And first step is done successfully. Next, try to define the global variables. Here, typedef keyboard is used to define the node as a pointer to struct node. After that, globally, there are 2 pointers that we have node header and node temporary is created with null. It means there is a header with null and also temporary with null. So global variable declaration part is done, then create the header node. For creating the header node, this is the function that is used. It means initially we are creating a dynamic memory by using the malloc function, and the size of this function is struct node. So struct node means what? We have total 5 fields. Later it returns a pointer that is pointing out to the node that we are creating, and here initially we are giving the values coefficient value as 0, all the exponential values as -1. So this is a header value which does not hold any information generally, and here we are using coefficient to store how many number of nodes are there inside the single linked list. So creating a header node is also done, then creating a node. So creating a node and creating a header node, there is no big difference, but creating a node do have the information. For example, if you have the term like 6x square y square z power 1, so this information need to stored with the node that we are creating here. Let us see what are the things that we can do with the create node, and who will give this information. This information will be given as input to the program by the user. So obviously we'll have printf and scanf functions inside this create node, where user will get a chance to enter the details like 6, 2, 2 and 1. If you observe here, create node, we are using a temporary variable, so that holds the similar to the header node. We are creating a node that is a structure that is of type struct node, and here we are asking the user to enter the details for the coefficient, exponential of x, y and z, and temporary of next is equal to temp. What happens when we call these two methods? Let us see. So let's take void main. Let me call the method create head node and create node. After calling these two methods, let us run the program. Enter the coefficient value. So the coefficient value is 6, x square, y square, z power 1. This is what happened. It has taken the input successfully. Until or unless we call the display method, we cannot see. Until or unless we call the display method, we cannot see the term in a proper way. When you call this method, create node and create head node, what happens in the backend? So the moment you call create header node, what happens is a new node is created that has the information 0, -1, -1, -1, and this would be pointing to itself. Header next is equal to header means it is pointing to itself. The moment you are calling the create node, if user is giving the input 6, 2, 2 and 1, and this is a temporary, and this would be pointing to itself. Observe here, temporary of next is equal to temporary. And we are doing one more thing, header coefficient value we are incrementing by 1. That means header coefficient value we are incrementing by 1. That means we are making sure that the update of one node that we are creating will change the total number of nodes in the program. Next, insert rare. Insert rare is very similar to what we are doing it for either single linked list or circular single linked list. The moment you call the method insert rare, so what happens is a new node named current is created. Create node is called. That means it goes to the create node function. In create node function, what we are doing? Temporary. Temporary is equal to what? Malloc. So temporary malloc. Malloc is a dynamic memory, and what is the size of this memory? Struct node. So what is the struct node? Coefficient, exponential x, y, z and next. So this is the size that we are decided. Next, after that coefficient. So if at all we are giving the coefficient value as 6, 2, 2, 1, here temporary of next is equal to temporary. So temporary of next is equal to temporary. Something like this is created. And already you have called create header node. It means a header node is created with the value 0, -1, -1, -1, and it is a next that is pointing to itself. The end header coefficient +1. So 0 + 1 is 1. That means we have created one node. Then it come back to this line. It will check header next is equal to header next. Header. So is header next is equal to header? Yes, because header next is pointing to header only. It means that there is not even single node in the single linked list. Now what are doing? Header next is equal to temporary. It comes to else, it does not come to the else part. It comes back temporary of next is equal to header. So temporary of next. So where it will be pointing to? It will be pointing to, instead of this, it is pointing to header. Now it is a single circular linked list with a header node. If at all you are calling this method one more time, if you are calling this method for one more time, what happens? Let us see. First, it comes to enters into the method insert rare and current. So a node current is created which would be pointing to any structure node. Then it calls the create node. When it calls the create node, what happens here? A new node is created. Consider we are giving some information like 4, 3, 2, 1. It means 4x cube y square z, and this would be pointing to itself. The moment you call the create node method, this is what happens. And at the end, header coefficient plus 1. So this plus 1, already 1 is there, 1 plus 1, it will become 2. That means total 2 nodes we have created. Then it comes to the if condition. In if condition, header next is equal to header. Header next is equal to header. This condition fails. When it comes to the else part, what we are doing is current is equal to header. If header address is 1000, what we are going to do? We are assigning this value as 1000. Now while current of next is not equal to header, current next. So is current next is equal to header? No. It means what we will be doing is, so current is equal to current next. Actually, what happens in the while loop here is, we would be traversing to the end so that we will be inserting node at the end. Current of next is equal to temporary. So what we will be doing once it comes, so current of next, this value will be updated over there. Automatically we'll be adding this by disconnecting this one. Current of next, this will be connected to the temporary, and this temporary of next will be connected to the header. That means last we are connecting to the header node, and previously this was the last node, right? That would be connecting to the node that we are going to insert. So this is how we are going to insert. At the end, we are printing the header coefficient, which is the value 2 on the screen. So let's execute this part of the code. The coefficient 6, 2, 2, 1. So total number of terms 1, and it is already inserted. Insert part is successfully done. Let us see the display part. When you call the display method, what happens is first node current. So current is a pointer that would be pointing to a structure node. Now here first what we are doing, if at all header next is pointing to the header itself, it means list is empty. That is very well known. After that, current is equal to header of next. So header of next holds the address of the first node, that is A. So what we are doing, current is holding the address of A. It would be pointing out to this. Later we will be printing the elements that are there here. So 6, 2, 2, 1. So since all the 6 is a positive element, it comes to the else part. When it comes to the else part, what we are printing? 6 through the current coefficient and power of x, power of y, power of z. If you observe this, what it prints is 6 x square y square z power 1. And if at all you are having minus 3, 2, 1, 0 in the next node, what we are doing? Current is equal to current of next. Current of next, currently current is pointing out to the A node. So next is holding the address of the next node. What is that? B. So we are updating the A value with B. Now we will be printing the element. So it will run in the while loop. It go back here. Current is not equal to header. Is current is not equal to header? Yes, current is not equal to header. Now what happens is B. So when we are seeing that here B is not equal to header, it comes here and it prints minus 3, 2, 1, 0. It prints like this: minus 3 x square y power 1 and z power 0. Z power 0 is nothing but 1. This is how it prints all the elements that are there in the singly linked list. The function to display the polynomial. Let us update here after inserting the element. So let us insert at least 2 or 3 elements, so that enter the coefficient 6 x square y square z power n minus 2 x cube y power 4 z power 1. So third time we are calling the insert rate, and you can see number of terms is updated automatically. Minus 3 x power 2 y power 0 z power 1. If you look at this, after that display method is called, which is displaying the elements here: 6x square y square z power 1 minus 2 x cube. So the term whichever we have entered on the top, it is displaying here. The moment you call the evaluate method, first x, y, z are the 3 elements. So x, y, z are the 3 values that we are taking. For example, if 6x square y square z is the term, if at all you take x value as 1, y value as 2, z value as 2. So that would be represented like this: 6 multiplied by 1 multiplied by 4 multiplied by 2. So whatever the answer you get, so this is the final answer that we are getting during the evaluation. Here we are traversing through the linked list, and every time we are updating the value and adding it to the result. And final, whatever the polynomial equation result that we are getting, we'll be printing it here. So let's copy paste this evaluate function and see what is the answer that you get. So this is the function to evaluate the polynomial equation for the given values x, y, z, and let us call this function evaluate and debug the program. Let us say 6x square y square 1 minus 4 2 1 2 2 3 4 5, and now it is asking the values of x. So let me give x value 1, z value 2, z value 3. We got 7776 as the answer. So already I cross verified, it is working perfect. So this is how we implement the complete program. If you observe here, we have taken an iterator for the for loop, and number of coefficient. Number of coefficient means how many terms you require in the polynomial. So if you want 5 terms in the polynomial, it will take the 5 values, and as per the objective of our function 6x square yz 4y z power 5, this expression if you want to print, you have to give the values of this type. Let us run this program. So enter the number of terms in the polynomial. Here 1, 2, 3, 4, 5. So 5 polynomial terms are there. 5 coefficient 6 x square y square z power 1 minus 4 x power 0 y power 1 z power 5 plus 3 x cube y power 1 z power 1 plus 2 x power 1 y power 5 z power 1 minus 2 x power 1 y power 1 z power 3. If you observe, it has taken and it is printing the actual expression, polynomial expression that we want. And if I give x value as 2, y value as 2, z value as 2, I got the answer 224. If you calculate, we'll be getting the same answer. And here end of the first part. Second part we will see in the another video.